Hello everyone, welcome to this webinar. So at this webinar, we'll be discussing about Kubernetes. Okay. So before starting this webinar, we'll wait for a minute or so for other participants to join, and then we'll move ahead with the agenda. So before starting this webinar, I would like you guys to give an introduction, like what is your experience in IT, whether you belong to IT or non-IT, and how many years of experience you have in IT. That will help me out you to guide throughout this webinar. Yeah, you can give your introduction on the chat or on the Zoom. You can unmute yourself and you can just give a short introduction of yourself. Hey, Sanchit, would you like to go ahead?
Hey Gaurav, can you hear me? Hello.
Yes, Sanchit, I can hear you.
Yeah. So my name is Sanchit Shah, and I'm basically.
Sorry, Sanchit, I think we lost you. Sanchit, can you hear us? Okay, Sanchit, we cannot hear you. Okay, no problem. Hi all, welcome to this webinar. Before starting this webinar, I would like you to just give your introduction about what experience you have in IT, whether you are from an IT background or non-IT background, and how many years of experience you have. So that will help me to guide you throughout this webinar. So feel free to unmute yourself and give your introduction, or you can type it on the chat as well. All right, now let us start with the webinar. So today in this webinar, we will be learning about Kubernetes. We will be going through what is Kubernetes and what is the demand of Kubernetes in the IT market. Okay, we'll be seeing.
Hello.
Yes, Sanchit, we can hear you.
Okay. So my name is Sanchit, and I'm from India basically, and I just landed in Canada in January month, and I'm a student right now. But back home in India, I'm having four years of experience working in TCS with a core Java, and
Mhm.
I'm looking forward to learn more about cloud technologies. So yeah, I'm looking forward to making some good networking over here too.
Yep. Thanks, Sanchit, for your introduction. That sounds better. That you are from an IT background. You are working in TCS, which is an IT company for last 4
Yeah,
years, and you are working as a developer, right? As a Java
like
developer.
I I was working as a Java developer. Right now, I'm a student here in Canada.
Oh, I see. Okay.
Yeah.
All right. So today in this webinar, we are going to learn about Kubernetes. So does anyone has any idea about Kubernetes? What is Kubernetes? Anything?
The container orchestration.
Exactly. So Kubernetes is basically a container orchestration tool. So before understanding Kubernetes, let us have a discussion about containers. Okay, because Kubernetes is a container orchestration tool. Okay, so if we talk about containers, so containers are the new way to deploy applications in the market today. Before containers, what we used to do, we had one server, and top of that server, we used to install some operating systems like Windows or Mac or Linux operating systems. It is called a host operating system. And on top of that, we used to run an application. We used to run an application. Okay, one application on one host. Okay, let's say if you want to run your Java application, or you want to run your Python application, or you want to run your web applications. So we used to run the application on one host. Okay, let's say I want to run a PHP application, and let's say I want to run a PHP 7 application. Similarly, I want to run an application which supports PHP 5. Okay, there are some applications which supports PHP 7, and there are some applications which supports PHP 5. But it is not possible to install two softwares on the same operating systems. Okay, let's say we have Microsoft Office. If you are using a Windows machine, you might have used Microsoft Office. So let's say if you are running Microsoft Office 2008, and let's say you want to run 2008 also, and you want to run 2012 also. Okay, Microsoft Office is also an application, and you want to run two versions of that application. So to run two versions of an application on a single host was not possible. With the help of containers, with the help of containerization, on top of this host operating system, we install an container runtime, which is just in software. We can call it container runtime. We can call it a container engine. Okay, and on top of that, we deploy the containers. Okay, now what are these containers? So these containers basically they have libraries and binaries. They have libraries and binaries which are used to deploy an application. Okay, let's say if I want to deploy a WordPress application. Okay, WordPress is a very popular application which is used to host blog sites. Now let's say if I want to host a WordPress application. So what are the libraries and binaries required? So we require PHP 7. Okay, we require a database, and we require some PHP extensions. Okay, so what this container has is, this container has all the libraries and binaries which are required to run that applications. Okay, and these containers are isolated to the host operating systems. Okay, these containers are isolated to the host operating systems. So in this way, we can run multiple containers on the host OS, and on multiple containers we can run multiple applications. Okay, we can run like Jenkins. We can run any application written in PHP, Java, or any application we can run on a Docker container. So this is basically the scenario which we are seeing here is if you want to develop application or if you want to test an application. So in that case, basically we have this scenario where we have an server. Basically we can call it as our hardware. Okay, hardware, which means it has our resources like processors, CPUs, memory, RAM. Then we have the host operating systems like Windows operating system or Linux operating systems. And on top of that, we install a container runtime or container engine, such as Docker. Okay, Docker is a very popular containerization platform. Okay, which is basically a container engine. This layer is also then we have our operating systems. Then we have the software, which is Docker. Another popular tools are Istio, Rocket. Okay, these are all containerization platforms, okay, through which we can create containers. So using Docker, we can create containers. Using Istio, we can create containers. Using Rocket, we can create containers. And what we can do in containers, we can host our applications. Okay, we can host different types of applications requiring different versions. Okay, different dependencies. Okay, do you guys have any questions still here?
No.
All right. Okay, so this is, you can say, the story of Docker. Okay, where we have one hardware, on top of that we have operating system, and top of that we have the container runtime. It can be our laptop or it can be our desktop. Okay, where we are running the containers. Now, as we discussed, this is basically used in the dev environment or the test environment. Okay, there are different environments to deploy an application, like development environment, testing environment. So let's say I'm a developer. So I have a laptop, and on top of that laptop, I have Windows operating systems or Linux operating system installed. And on top of that, I have Docker installed. And using Docker, I can deploy the application which I'm writing, and I can test that application. Okay, whether the container has, or we can say whether the application has supports multiple programming languages. Okay, so instead of installing those programming languages or installing those softwares in my machine, I can simply deploy a container to host those applications. So this scenario, this architecture is basically for developers and testers. Now, in production environments, we use a tool called Kubernetes. We use Kubernetes. So what is Kubernetes? Kubernetes is a container orchestration platform. Okay, what does container orchestration means? So in container, in Kubernetes, we have more than one node. Okay, let's say this is one server, this is another server, and this is another server. So we have minimum 2 servers, okay, in Kubernetes. And we have the same architecture. We have the server, we have the host operating system, we have the container runtime, and on top of that, we have Kubernetes running. Okay, this is our server. And on top of that, we have the host operating system. And on top of that, we have a container runtime, such as Docker. And on top of that, we have Kubernetes. So what Kubernetes is doing, it is basically managing the containers. Okay, it is orchestrating the containers. Okay, let's say if you want to deploy an application in production. Okay, in the case of Docker, let's say this is the Docker environment where we have only one host, one server. Now let's say if this server gets down, okay, due to any reason this server gets down, so the application will be down. The application running on the server will get down, okay, which will have a downtime for our application. So what Kubernetes does, in Kubernetes we have at least two nodes, one master node and one is the worker node. Okay, we have a master node and we have worker nodes. Okay, these are nothing, these are our servers. Now the same container, the same application which we used to deploy in Docker on a single host, what Kubernetes does is it basically deploys those containers to worker nodes. It will deploy those containers on the worker nodes. Let's say one is my PHP application, one is my database container. Okay, let's say one application we have is of PHP and another we have a database like MySQL database. Same here. So the same application we are running in two servers. Okay, the same applications we are running in the two servers. So can anyone tell me what is the advantage of running the same application on two servers? Yeah, it provides load balancing, plus it provides high availability. Okay, load balancing, it means like when we will be trying to access the application, first request will go to this server, then the second request will go to this server. Plus it will ensure that let's say one host gets down, so there will be another host which will be accepting the connections. Okay, there will be one host which will be accepting the connections. So Kubernetes basically provides us high availability, HA, high availability, and it provides fault tolerance. Okay, so Kubernetes provides us high availability. It provides us a fault tolerant environment. Okay, so let's say if you are running your application on the container and if your one host gets down, so there will be another host to accept the request. It means your application will not go down. And these containers basically will deploy through the master node. This is basically our master node. So using Kubernetes master, we orchestrate the container deployment. Okay, we can deploy like hundreds or thousands of containers using Kubernetes. So the biggest difference between Docker and Kubernetes is Docker is good for like if you want to run 50 or 100 containers. Let's say if you want to run 1,000 containers, 1,000 to 2,000 containers. So in that case, Kubernetes is the best known platform in the world today. Okay, do you guys have any questions still here?
I hear that OpenShift is really popular. Is OpenShift same as Kubernetes?
Yeah, OpenShift is basically running on top of Kubernetes. Like we saw one layer of Docker, and top of that Docker we have Kubernetes. OpenShift is running on top of Kubernetes. Okay, it is also a containerization platform, and it is running on top of Kubernetes. And OpenShift is basically used in enterprises. Okay, it is used in enterprises, and it is basically a product. Okay, whereas Kubernetes is an open source project. Okay, Kubernetes is a project and OpenShift is a product which is developed by Red Hat. Okay, and OpenShift is basically a platform as a service solution, whereas Kubernetes is a container as a service solution. Yes, go ahead.
So if you write, so can you write same code in for Kubernetes and it runs the same on OpenShift?
Exactly. Same deployment files, same pod definition, same services which we write in Kubernetes will work on OpenShift. Kubernetes is basically the core of OpenShift. Without Kubernetes, OpenShift cannot work. And without Docker, Kubernetes cannot work. So all these three are dependent on each other. Okay, now let us discuss about some of the master components. So this architecture which we are discussing about is basically the on-prem architecture.
Hello, excuse me. Can you repeat what Kubernetes depends on?
It depends upon a container runtime. It depends upon a container runtime or container engine, such as Docker, Istio, or Rocket. These are, it depends upon Docker, Rocket, or Istio. There is also one more popular new container platform available, which is Creo. Okay, so these are all container runtimes, okay, through which we can deploy containers. So Kubernetes basically works on top of these container runtimes. And even these worker nodes are also running Docker. They have a layer of Docker. Okay, first they have the server and top of that operating system, and then on top of that, Kubernetes is running. I mean, Docker is running.
Can I ask a question?
Yes, yes, please.
So could you start with just using Docker and then later add the Kubernetes if you need it?
Yeah, actually we can use Docker, but Docker is used for small environments. Like when you want to run the application, small application, which will be like of running like 20, 30 containers. In that case, basically we use Docker.
Okay.
And if you want to run an application in production environment, which is basically in the live environment, so in that case, basically we use Kubernetes, which has more features as compared to Docker.
So in a production environment, when you say production environment, are you saying even with 20 or 30 containers, you would use Kubernetes in a production environment, or would you, when you say production, you're really talking about thousands?
It can be 30 or 40 containers or 50 containers. The advantage of using Kubernetes is we can create namespaces in Kubernetes. This is another concept of Kubernetes, which means we can create namespaces in Kubernetes. So with the help of Kubernetes, we can directly run dev environment, we can run prod environment, okay, we can run testing environment, we can run the staging environment. Okay, these are the environments which basically any organization has in the software development cycle. So inside the same cluster, we can have this environment. These four environments basically we can deploy on the same cluster. That is the biggest advantage of using Kubernetes. And same concept is in OpenShift also, which is called projects. So there are some more features which makes Kubernetes better than Docker. Okay. Like in Kubernetes, we can run, let's say, if we want to run some internal applications, okay, let's say databases. Okay, we don't want databases to be exposed by the users. Okay, let's say these are customers. We only want the customers to access the PHP application, which is the front end of the application. We don't want them to access the back end of the application. So that granularity we can do using Kubernetes. Okay, we can create an internal service which will be accessible inside the cluster, which will not be accessible outside the cluster. Okay, which makes Kubernetes more secure as compared to Docker.
Does Ansible relate to Kubernetes?
Ansible is basically a configuration management tool. Okay, Kubernetes is a container orchestration tool. Okay, Ansible is basically used for managing host. Let's say there are 10 servers, you need to install some softwares. So in that case, basically we use Ansible. Okay, it's basically a configuration management tool. Let us see the architecture of Kubernetes. Also, the architecture which we just saw, this is basically the on-prem environment. On-prem, it means the traditional environment where earlier company used to deploy the application. Okay, where they used to purchase some servers, they used to install operating system, and everything they used to manage. But after the cloud, all these servers which we are seeing are running on the cloud environment. And almost all the cloud providers, all the giants such as AWS, Google Cloud, Azure. Okay, these are the main cloud players in the world, out of which AWS has a solution for Kubernetes, which is EKS, which stands for Elastic Kubernetes Service. Google has a solution for Kubernetes, which is Google Container Engine. Azure has a solution for Kubernetes, which is AKS, Azure Kubernetes Service. So if you see any cloud platform is providing Kubernetes on the cloud, which means we don't have to deploy any server. Everything will be deployed by them. We just need to deploy our application. So Kubernetes has a high demand in the market. Okay, it's like earlier we used to deploy the applications on a single server. These days we use containers to deploy an application. So that basically falls under DevOps too. That's why Kubernetes also comes in a DevOps tool, which is used for orchestrating the containers. Okay, so in Kubernetes, we have two nodes. Okay, minimum we have two nodes. One will be our master node and another will be our worker nodes. So master node acts as the primary control plane for Kubernetes. Okay, which means all the containers which we are going to deploy, we deploy using the master node. And master node basically manages the whole cluster. Okay, cluster means there will be, as we just discussed, there must be single node, one node. There can be hundreds of nodes running in the Kubernetes cluster. Okay, and the management of those nodes is taken care by master node. And then we have the worker nodes. Okay, and in worker nodes, basically we run the containers. Master node doesn't run the containers, only the worker nodes run the containers. So this is the high level architecture of Kubernetes, where we have a master node and we have two worker nodes. Okay, the same diagram which we saw. So here in master node, we have several components, and node we have some components. We have load balancers, we have cloud providers, we have end users who are accessing our application. So in the master node, we have the API server, which is basically the heart of the Kubernetes cluster. Okay, if we don't have an API server, so our Kubernetes cluster cannot work. Okay, because basically API server basically takes care of the whole cluster. Okay, the containers which we are deploying, all the information is basically transferred through the API server. Then we have kube controller manager, kube scheduler, kube proxy, and additional services, which depends upon where we are deploying the Kubernetes cluster. Then we have a etcd platform, okay, which is basically a key value pair database, okay, which stores the cluster information. Okay, and we have the container runtime. Okay, in most of the cases we have Docker. Okay, Docker is more stable for Kubernetes. Then we have an agent installed in the master server, which is kubelet. And the same architecture we have in the worker nodes. We have the container runtime and kubelet, which means we have Docker installed and we have an agent installed, which is kubelet. And on top of that, we have kube proxy. Kube proxy, basically what it does, it allows the containers running inside the cluster to communicate with each other. And then we have pods. Pods are basically the containers. In Kubernetes language, we call a container as a pod. And inside pod, we have our containers running. Okay, there can be more than one container running inside a pod. And now to access those applications which we are running in our Kubernetes cluster, we have a load balancer, which is basically provided by a cloud provider such as AWS, AWS, Azure, or Google Cloud, and through which our end users access the application which is running in our Kubernetes cluster. Okay, so this is the new way to deploy applications in the cloud or in the on-prem infrastructures. Okay, do you guys have any questions till here?
So you never have the master and node to be the same. So is master machine specification weaker than node because never run the pods?
Yeah, actually master node has low configuration as compared to worker nodes, because worker nodes are running the containers. Okay, like let's say our master node has 2-core CPU and 4 GB of RAM. Our worker nodes will be having like 4-core CPUs and 16 GB of RAM, because worker nodes are running the containers. Master node basically what it does, it just splits the containers equally on the worker nodes. Okay, let's say from the master node we have deployed 10 containers. So let's say we have two nodes. Okay, and master node has deployed 10 containers. So it will equally distribute the containers among the hosts or among the nodes. So 5 containers on node 1 and 5 containers on node 2. Plus it will also take care of, let's say if one of the application, or let's say one of the container fails or one of the container dies. So Kubernetes master will take care of creating that container as well. So all these things are taken care by the Kubernetes master.
Is it good to have like more than one master to communicate with each other if one fails?
Yeah. You're coming at the right direction. That is basically for high availability. Okay, let's say we have one master in our Kubernetes cluster, and let's say the master gets down. Okay, due to some operational issues, the master gets down. So in case if we have multiple masters, okay, like master 1, master 2. So if let's say one of the master gets down, so there will be another master available to accept the, to assign pods to the nodes. Okay, this kind
So
of
if a node fails, a master can create a new node, but if a master
not the
fails,
node.
can another master create a new master?
No. Node creation is not done by the masters. Only the pod, only the container creation is taken care by the masters. Node creation is taken care by the administrator, the cluster administrator, the Kubernetes admin takes care of the nodes. And container is basically taken care by the Kubernetes master. So if we have, let's say if we have only one master, so let's say if this master gets down, so there will be no master available to schedule the containers or deploy the containers. So in that case, basically we have multiple masters. Okay, if let's say one gets down, there will be another master to schedule the containers or deploy the containers on the cluster. Now let us discuss about some of the components in the Kubernetes master. So these are the 5 main components in the master machine, which is the Kube API server, okay, which is also called the heart of the Kubernetes cluster. We have etcd, which is a database, key value pair database, which stores the cluster information. Then we have Kube controller manager, okay, basically it takes care of deploying containers on the worker nodes. And let's say if you are running our Kubernetes cluster on a cloud platform such as AWS or GCP or Azure, so in that basically we have a cloud controller manager, which takes care of deploying the containers. Then we have Kube scheduler. Okay, so the task of the Kube scheduler is to deploy containers on the worker nodes. Okay, deploy containers on the worker nodes plus to make sure the desired states of container are running. Let's say we have one master node and we have one worker node, and we deployed our application with 10 containers, okay, which is basically called replicas. Okay, we deployed our application with 10 replicas. Now kube scheduler will take care that minimum 10 containers are running inside the cluster. Let's say due to some reason some containers get down, so automatically kube scheduler will create the containers instantly. Okay, this is the architecture of the master node which we just saw, and basically we have kubectl. Okay, through kubectl, basically the Kubernetes admin or the Kubernetes developer basically sends commands, or you can say sends deployments to the Kubernetes cluster. Okay, it basically interacts with the master machine, and inside the master machine it interacts with the kube API server, and the kube API server interacts with other components. So basically kube API server, by the name itself, it's basically an API server through which we can deploy containers. Okay, it interacts with all the components inside the cluster, and all clients including nodes, users and other applications interact with the Kubernetes strictly through the API server. Okay, if we see this diagram, so if you see, there are all arrows which are interacting with the API server. The user kubelet is basically the Kubernetes admin. Okay, it is basically a command line tool to access the Kubernetes cluster. Okay, like Kubernetes, this is the server, API server. So to connect to a server, we need a client. So kubelet is a client through which we can connect to the API server, and through the API server we can deploy our containers in the Kubernetes cluster. Then, as we discussed, we have a etcd database. So etcd acts as the cluster data store, providing a store consistent and highly available key value store used for persisting cluster state. So etcd basically stores the cluster information, like how many containers are running in the cluster, how many nodes are there. Okay, it checks the health of the nodes. Everything is taken care by the etcd. Then we have the controller manager. So the controller manager is the primary daemon that manages all the core components, control loops. It monitors the cluster states via the API server and steers the cluster towards the desired state. Okay, so Kubernetes controller basically makes sure that all the nodes which are running in the cluster are up and running. Okay, if there are any cluster, I mean any worker node which is not healthy, okay, healthy it means it is not ready to schedule the pods. So Kubernetes controller basically marks that node as a not ready or unhealthy node. So that those things are taken care by the control manager. So if you are using a cloud platform, then we have cloud controller manager. Okay, such as EKS, or we have Google Container Engine, we have Azure Kubernetes Engine. Then we have kube scheduler. Okay, so what the scheduler does, it basically sends the container based on the nodes configuration. It assigns containers to the worker nodes based on their configuration. Okay, let's say we have one worker node with 2 core CPU and 4 GB of RAM. And let's say my application requires 4 core CPUs and 8 GB of RAM. So kube scheduler basically takes care that which hardware or which node to assign the pod to, or which node in the cluster to assign the container to. Okay, do you guys have any questions about the master components? Now let us discuss about node components, or which is also called a worker node. So in node we have 3 things. One is the kubelet, which is the agent. Okay, we have kube proxy server, which is basically used by containers to communicate with each other. Then we have container runtime engine. Okay, we have a container runtime engine, which is Docker, Istio, or Rocket. So these are the components in the node. We have kubelet, which is basically the agent. And all the worker nodes, basically we have the kubelet installed, which is basically the agent. And kubelet basically deploys the container inside the worker nodes. It takes orders from the master node, and then it applies those changes or deploys those containers inside the worker node. So we have three things running in the worker node. One is the kubelet, which is the agent. We have one container runtime, which is Docker. And on top of that, we have kube proxy server, which allows containers to communicate with each other. And in Kubernetes, we call a container as a pod. So as we discussed, kubelet acts as the node agent responsible for managing pod lifecycle on its host. Kubelet understands YAML containers manifest, that can be read from several sources. Now let's say if you want to deploy an application on the Kubernetes cluster. So we deploy it using a YAML file. Okay. YAML stands for yet another markup language. So this is the language which we use, which is basically a human readable language. It is far much easier than other programming languages. That's why it is called a human readable language. So using YAML language, basically we deploy containers inside our Kubernetes cluster. Then we have kube proxy. Kube proxy basically manages the network rules on each node and perform connection forwarding or load balancing for Kubernetes cluster services. Okay, it allows all the components which are running in the Kubernetes clusters, the containers, the services, the deployments, all of them to communicate with each other. Then we have container runtime. With respect to Kubernetes, a container runtime is a CRI, container runtime interface, compatible application that executes and manages containers. Okay, so the examples are Docker, Creo, Rocket, Kata, and Wordlet. Okay, so these are some of the popular container runtimes available in the market. And then we have some additional services which are running inside the Kubernetes cluster, which are kubedns, which is basically used for name resolution. Okay, name resolution, it means, let's say if you want to deploy your application in the production environment and you want to map it with a domain, okay, such as example.com. So that we can do using the kubedns. And also it basically allows the internal services which are running in the Kubernetes cluster to communicate with each other by a name. Then we have Heapstar. Heapstar is basically a metrized controller for Kubernetes cluster. It's basically used for checking the health of the Kubernetes cluster, like the CPU utilization, the resource utilization. Okay. Also, it is used for auto scaling the containers on the cluster. Okay, based on the traffic. Then we have Kube dashboard. So this is, as we saw the whole Kubernetes cluster, everything is managed by the CLI. Okay, everything is managed by the kube control, which is basically a CLI tool. So Kubernetes dashboard is basically a graphical user interface through which we can manage the whole cluster. But it is not powerful as compared to the kubelet. As compared to the kubelet, kubectl command line. Okay, it is not powerful as compared to the kubectl command line. Okay, do you guys have any questions till here? Okay, so now let us discuss about the program offerings which we offer. So we basically offer trainings in cloud, live training, one-on-one training and group training in cloud. We give training on Kubernetes, Docker, DevOps, okay, with all the tools which are, or we can say essential tools in DevOps, like Ansible, Terraform, Puppet, Docker, Kubernetes, Git. Okay, so we give all those training in the DevOps course. Also, we have some dedicated course for Docker and Kubernetes, okay, which is dedicated for this certification exam. Okay, there are some certification exam as well for Docker and Kubernetes. For Kubernetes, the certification exam is Certified Kubernetes Administrator. Okay, which there are two certification. One is Certified Kubernetes Administrator, another is Certified Kubernetes Developer. And Docker, we have Docker Certified Associate. That is the certification of Docker. So to register for the class, you can directly contact Matt, which is the meetup organizer. And then in the next webinar, we'll be having of DevOps, where we'll be discussing about different DevOps tools. And also, we are starting a batch of Docker this weekend. I mean, on the next weekend on Saturday, we are starting a batch of Docker, where that is basically dedicated for the certification of exam of Docker, which is of 6 hours. Okay, so you can go to this website, codingbootcamps.com, or you can directly contact to Matt. He basically manages the registrations and enrollments part. And after this Docker batch, we will be having a Kubernetes batch, because before learning Kubernetes, we must have an understanding of Docker. As we saw, like Docker is running on top of Kubernetes. Sorry, Kubernetes is running on the top of Docker. Okay, I'm sharing the PPT on the chat. Okay, do you guys have any questions still here about the classes or anything which we discussed in throughout the session?
What do you use to spin up a node if a node dies? Kubernetes doesn't do that, but what do you do to?
Yeah, that
to
is actually
recover
taken
master
care by
node?
the. Actually, that is taken care by the Kubernetes administrator who is deploying the cluster. Okay, let's say this is the master node and 2 worker nodes. And to manage the whole cluster, we have a Kubernetes admin who interacts with the master node through the kubectl, which is basically a command line tool to interact with the master server. So this Kubernetes admin, using the kubectl command line, sends commands to the master node, and based on their commands, master node basically deploy containers or deploy services on the worker nodes. Now let's say if you want to scale up your nodes, or let's say one of the node gets unhealthy. Okay, so if you are running this on a cloud environment, so automatically you will get a notification that the host is down. Okay, if you are running it on an on-prem environment, so then you have to monitor the worker nodes. Okay, or the whole cluster you have to monitor manually. If you are running on the cloud environment, once the node get down, you can create an alarm. Once the node gets down, automatically you will get a notification from the cloud provider that the node is down. And the Kubernetes administrator then takes some operations like deploying a new node. Okay. Also, if you are running it on the cloud environment, so in the cloud provider itself takes care of the nodes. Okay, now let's say we have deployed the cluster with 2 nodes, and let's say this node gets down. So what does cloud provider will do? It will automatically spin up a new worker node. Okay, that is possible due to through auto scaling, which is available in AWS cloud platform. It basically will ensure that minimum 2 worker nodes are running inside the cluster. So that basically ensures high availability, and it also ensures fault tolerant environment.
Can I ask a question?
Yes, yes, please.
And I think we say that Docker may not be good enough for production environment, but Kubernetes is. I'm not sure.
Docker is basically, yeah, Docker is basically used for deploying application in the dev environment or testing environment. It is not used in the production environment. Some companies are using Docker also in the production environment. In Docker also, we have a container orchestration tool available, which is Docker Swarm. And that also we can have master nodes and worker nodes running. Okay, but that is good for running in the development environment or testing environment. For the production environment, we usually use Kubernetes.
Why we don't use Docker, or why it's not suggested to use Docker in production?
Because Kubernetes has more features as compared to Docker. Okay, as we discussed about namespaces. So we can create different namespaces where we can run our different environments. So this concept is not in Docker. Okay, if you have like one Docker node, okay, one cluster of Docker where you have 3 machines, so that will be only running the dev environment. Then let's say if you want to run a production environment, then you need another 3 nodes to run the production environment. But the same thing we can do inside a single cluster of Kubernetes. And there are some other more features available in Kubernetes, which are security. Okay, there are some security constraints and role-based access control on the cluster. Okay, those things are available. As compared, like we can create users in Kubernetes to provide access to the cluster. Let's say my developer wants to access the Kubernetes cluster. He wants to deploy an application. So I will be providing him access to the master node. Okay, I will not be providing him access to the whole cluster. The Kubernetes admin has access to whole cluster. The Kubernetes admin can do anything inside the cluster. Okay, it is kind of root user in Linux. Like the root user can perform any operation in the machine. Similarly, Kubernetes admin can perform any operation in the cluster. But using Kubernetes, there is a concept of RBAC, role-based access control. So using that, basically we can restrict access to the control to the cluster. Okay, also we can limit the access to the cluster by namespaces. Now let's say if I want to provide my development team to the dev namespace, so that can be done. Okay, so they will be only able to access the dev namespace instead of getting access to all the namespaces or all the environments. Okay, do you guys have any other questions? Yeah, please download that PPT which I shared on the chat. You will be able to see what are the upcoming programs, the webinar, okay, and the classes which we have. Also on the next weekend, we'll be having a certification training of Docker, which is of a Docker Certified Associate, which will be of 6 hours, where we'll be covering all the concepts in Docker from one node to a Docker Swarm cluster. So to enroll in the course, you will get the information in the PPT. All right, so guys, let us end up the session here. So we'll be having another webinar on the next week of a DevOps. Okay. So yeah, all right. Thank you everyone for joining. Have a good day.
Thank you so much.
Thanks. Yeah.